very good morning, class. Sorry for the delay. So we are actually continuing on creating time delay using program loops. So yesterday we have already seen one example on how to actually create a time delay. So today we're going to continue with the example. So similar to yesterday, but only thing is now we have a longer duration of time delay. Frequency given is the same. So here I have broken down into the steps of how you want to create the time delay. So the first thing is you need to find out the duration of one instruction cycle. So you know that the duration of one instruction cycle is equal to 4 times the clock cycle period, which is 1 over frequency to get the duration. So because the frequency oscillation is 40, so you get to know the duration of one instruction cycle is 100 nanosecond. Why we want to know the duration of one instruction cycle? It's a question. You are looking at me like this is skip one. Why are we interested in finding out the duration of one instruction cycle? Because we are going to use instructions to actually create the program loop. So we need to know one instruction, and you know that we're going to use NOP from yesterday's example. So NOP takes one instruction cycle. But in order for you to create a time delay, you need to know that one instruction cycle takes how long. So therefore, that's why we want to calculate this one instruction cycle first. So we found out that it's 100 nanosecond for one instruction cycle to be executed. So remember yesterday that we have this approach of creating the basic time block of 2 microseconds. Really, of course, yesterday in the example we saw that you can change this value. Not a problem. You can choose a bigger one or smaller one. But don't choose anything smaller than this. This is small enough already. If you want to choose, you can choose anything bigger than this, provided that whenever you divide, you get a value which is less than 255. So here, the next step is to find out the number of instruction cycle created to create the basic time block of 2 microseconds. So because we are taking this approach, that means we are creating a basic time block so that we'll know how many times to loop that basic time block to achieve our required time delay. Are you all following? Yes. So the number of instruction cycles required is, if the basic time block is 2 microseconds, how many instruction cycles do we need to achieve 2 microseconds? So you know that one instruction takes 100 nanoseconds. So simple maths, you just divide, you'll know the number of instruction cycles required. So you need 20 instruction cycles. And then, because this is the basic time block that you have created, we need to find out how many times now we need to loop these 20 instruction cycles. Because these 20 instruction cycles takes 2 microseconds, right? We need to know how many times we need to loop these 20 instruction cycles to achieve the desired time delay. So again, a simple math. So the desired time delay divided by basic time blocking. So you know how many times to loop. So the the required time delay is 100 milliseconds divided by the basic time block. So how many times you need to loop? 50,000 times. Is this valid? No. 50,000 times? No. You won't be able to do in one loop. You need to do more than one loop. Okay? So yesterday's example, how we actually did was, we know that you need to have a loop counter. And then you have this loop value, right? I just had back yesterday's one. Then here is the part where you have the macro. Then you have your program template. Then here's where you have your main program. main program what we did, we actually removed this one is I'm referring to yesterday's example. Then we move pattern of working register to count. Then we call duplicate no operation.
Duplicate.
Yes, duplicate operations. This was yesterday's example, right?
Yeah.
This is yesterday's example. Yesterday's example was 250 times you loop. But now, you have to loop this 50,000 times. It's not possible for you to load 50,000 to working register because the maximum you can load is 255. So therefore, what we need to do is now, we still can do it, but we cannot do it in one loop. This is actually one loop, single loop, right? Now you have to do nested loop. You have to have double loop. So how do you find out which loop to have which value? So what you do is, the moment that you get a value more than 255, what you do is, you divide with the magic numbers. The magic number which I prefer is 250. So when you divide with 250, what do you get?
200.
200. So you get 200. So what is this 250? Because you know that it's already more than 50,000, more than 255. You just divide with 250. The remainder you get should be also less than 255. If it's more than 255, again you can divide with the number 250. So now the first loop you can have 250 times. The second loop you can loop 200 times. So you know that 250 times 200 you get back 50,000. Understand? So this is for the first loop, this is for the second loop. So now how do you actually add another loop? So this is yesterday's example. So if you want to add another loop, you need to have another loop counter and another loop value, right? So let's see. So loop count 1. So you need to have the second loop counter 2. I'm assigning to another address. And then I need to have the first loop value.
Out of range.
What?
Out of range. I mean, the area there is not included in the recording.
Until where you can see?
Yeah.
This one.
This one.
This part can be.
This part, yeah.
Can I just assigning to the second loop counter, and then you need to have loop value 1 What should be the value of the first loop count?
250.
Actually, it doesn't matter, you can stop now, 250 or 200. Doesn't matter. Looping means it multiplies. And then the second one? Is okay? And then you're going to have your certificate of operation macro. Then you will have your, don't go try in test every time. This is only the class understand. Then you have your main program. Can I write the main program here? I'll just hide it here. It won't have space. So here I just continue this side. So you have to start. So what you're going to do is you're going to load the first loop value into the first count. And then you're going to load the second value into second loop count. Then you're going to call the duplicate of operation. Sometimes you need to do this one properly. 20, right? So same. 50 minus 3, 70. And here you have decrease binary skip is 0. This should be your loop count. Which one? 1 or 2?
Good.
It should be 2. So should be not 0. Okay, this is actually a duplicate operation. See this pattern, that always it will be sandwiched like this. Move value, move LW will loop well, move WF will be paired with decrease and branch again. So if here you are using loop count 2, here must be loop count 2 because it's always a pair with this. So this loop, how many times you are rotating this? 200 times. When this one finishes 200 times, it will go out of the loop, right? So you need this pair. So you need to decrease again. Because this 200 times you need to loop 250 times. So you have another decrease by 0. Simply loop 1. So do you see that this one and this one is a pair, and this one and this one is a pair. So it always comes like a sandwich. So So the more loop comes, then you add another one. But the structure remains like this. So now this branch again should go where?
Okay. Okay.
This again should go where? The same as the one. Where shall you go? Yes. Should go to duplicate operation. That is the internal loop. Okay, this way should go here. But here you want to loop 200 times. Again. It should loop this one for 200 times. Once this finishes 200 times, what happens? Loop count 0 will become 0 and it will skip to this one. So this one branch again should go where? Branch again 1. Where should it go? Okay, what just happened to loop count 2? What just happened to loop count 2?
Become 0.
I know. When it will come here? When will the pointer, the loop, will actually come here? After what? After loop count becomes what?
0.
Loop count becomes 0, then only it will come here, right?
Yes.
So where should the again go? Where should this again one be?
Decrease.
Okay, just give the answer. Yeah? Same? Yes? No. You all just told the answer. You all just mentioned that loop count 2 became 0. So where should the again go? Again 1 go?
Decrease.
Move out of the loop.
Loop count. Decrease. Loop count.
Loop, okay, here's the hint. Loop count 2 has become 0. You need to run it again. What should you do?
Move out of the loop.
Yes. You should come here. Your loop count is already 0. That's why it's coming here. So when you go branch again, you need to run this thing again, right? This one already run 200 times. But remember this 200 times, you need to run it for 250 times. So now because loop count 2 is already become 0. So a branch again one should go here so that you can again load back the value of 200 to loop count 2. Then only this loop will run again for 200 times. For the second time. So like that this loop need to run for, this 200 time loop will need to run for 250 times. So the branch again should come here. You need to load back the loop value. Does it make sense? Any question or something? So always remember, if you do something like just now, some value that you get, then you divide it 250, again you get a value which is larger than 255, again you divide it 255. So if you have another one more time, if you divide, then you need to have another one more. The principle is the same. The other loop will reload back this one. So it has the same structure, provided that if you understand how the structure works. That's why I have divided this. Make it like a sandwich format. Talking about sandwich, doesn't that make you hungry?
Yes.
Any question on this loop? Now sometimes, of course I have already erased it. When we just now we divide 100 millisecond with the basic 2 microsecond, that's why we get 50,000. Now, if you have a bigger basic time block, of course, naturally you can understand that the loop you can decrease. So sometimes you can experiment. But remember the rule is, as long as the basic time block doesn't create an instruction or doesn't require a number of instructions which is more than 255, then it's fine. So you can try to play around those things. So at most, last time it came up to 3 loops. So it depends on how you do the calculation. You can have 103 loops. Is it okay? Any question? Can you understand? Shall we see the cheating method?
Fine.
So yesterday Hasman was asking, we actually did the long way because we need to understand the certain principles. Hasman was asking, yesterday was just yesterday the time, okay. Another method is, first you find out duration of one instruction cycle like this now. So how you do that? 64 multiply. So this one will change if you are given a different value. And then Anu is telling find out required. So from yesterday's example, yesterday's example shows the time delay. 5 milliseconds, right? When you divide with 100 nanoseconds, the value gets 5,000. This was yesterday's example. For today's example, get 100,000.
Yeah. 1 million.
Yeah, 1 million.
Yeah.
Okay, see that
Basic time block.
because the number of instructions cycle required because you're dividing with the duration of one instruction cycle. So you need 5,000 instruction cycle, you need 1 million instruction cycle. So the thing is, you can actually serially modify from here without using the duplicate operation. Can I erase this part? Okay, for the first one, this second method is not using duplicate operation. Straight away, This instruction takes how many cycles? Sorry.
One.
It's actually one cycle, right?
Yeah.
This will take
Two.
So more or less, you're going to cut off this duplicate operation. You straight away going to find the number of loops. Because here maybe it's 2, but it won't contribute much. This is the cheating way. So what you do, this 5,000, you straight away take it as the number of loop that you need to loop. So this one you divide with magic number 250. What does you get? You get 20. So the same thing you can actually do, but right?
25 limit dalam satu loop. Sampai dia suka bila kosong. Sebab memang itu satu loop.
Because the value inside here is 250, the value inside here is 320. So basically you are doing extra round from yesterday. Yesterday the same example for 0.5 second. By using the basic type block, we only have one loop, right? Which is 250. So if you want to remove the duplicate operation, it will become 2 loops. Of course, it's not so accurate because you'll have additional cycles here and launch again here. So this one straight away, what you do, this second way is straight away the number of instruction cycle required, you make it as the number of loops that's required. So the 5,000, that means you're going to loop this instruction 5,000 times. Which means launch again, you are looping this one, this is one instruction cycle. You will loop this 5,000 times, you will loop this for 20 times and you will loop this 200 times. This is one instruction cycle, this is one instruction cycle, so you multiply, you get 5,000 instruction cycles. This is the second cheating way. The second one, because it's 1 million, so divide 250, again divide with 250 and I think you need to divide the so it becomes more loops. So this is also possible. This is also possible. So this is the second way of doing it. So the advantage is for second one you don't have to write the duplicate operation, which means you do not have to declare the duplicate operation on top. Yeah. This one? There's no. Because just now when we calculated the number of instructions that we need to create the basic type block is 20 instruction cycle. This one takes 17, this one takes 1, this one takes 2. So total 20. This is always 1. So this is the method 2. This is the funnel. Without all the basic Anyone has any good video editing software? Because the Windows Media Maker is killing me. If you have, you can share. If you don't have, you can. Just rendering the video, loading the video takes ages. So, this time delay part, can you understand? Do you have any question on this time delay part? When you go back home, try to have a time delay more than 100 milliseconds. Try to experiment 3 loops. Then try to play around with the basic time block. Try to make it bigger. Can you see how can we reduce from 3 loops to become 2? And then you can, if you want, you can try the second method. Straight away doing it if possible. Come follow. So if by practice only this loop, you can actually understand. Then you will understand the structure of this sandwich thing. I already divided so that you can see it easily. Always it pairs like that, huh?
Itu yang ini yang saya lock. Dia kasih buat kita sendiri tetap. Pendek.
تعرف 250 انت المفروض الرقم يجيك في الحدود دي.
Amani, Sami Isham, Sami Kaijen, Muhammad Daniel, Daniel Ashraf, Muhammad Faiz, Muhammad Naim, Naim, Muhammad Abdul Salam, Farag, Ali Farag, Muhammad Nadirul, Muhammad Syafiq, Muhammad Syafiq, Muhammad Syarif, Muhammad Aizat. Why suddenly attendance very that big? The thing is, of course we have the video. Muhammad Faiz, Muhammad Azman, Muhammad Syafrul, Nabin, Nanda Kumar, Nur Hayati, Nur Syafiqah, Okay guys, after next year, next week, will it be possible for us to have also class on Friday evening?
Friday cannot.
Friday evening?
Friday evening cannot. Got random.
Already have random. Friday night?
Night.
Friday night. I know you won't have test 2 so early. If it's okay, then we'll discuss next week. The Tuesday we keep because I was thinking if we can have extra class, we try to catch up more. If you go advanced, then that's fine. Rather than doing extra class towards the end. So we'll discuss about another class on the Friday thing. Nur Syafiqah, Parvinish,
Dari segi cara di dua
Sasi,
macam kita cari interaction
Sarina, Syafi, Syafika,
بس انا هاي لي ثلاثة راجع البيت ولا؟ لا لا معك لا والله لا لا والله الحين اليوم عنده ورا التست ما عليه الغنية ما رحت الجيم قلت إذا رحت ما حقدر أكون نشيط كذا هذا صاحب القاعد صحيح رجله حاجة
Mas Syami,
كم سنة؟
Amir Ashraf, Albaya, Atika, Dennis Lim, El Tayyib, Aziz, Samadez, Ikmal Ubaidullah, Musa, Gayatri, Vaishen, Magid Hassan, Mohammad Hassan, Safwan, Mohan Raj, Muhammad Ahmad, Ahmad Zaini, Muhammad Shafiq, Muhammad Imran, Muhammad Akmal, Muhammad Arif, Muhammad Ashraf, Muhammad Hafizi,